Hi friends, it's been a few days since my latest video, and that has a simple explanation. I got hit by the disease which should not be named, but now I'm feeling better and I am ready to start a new series of videos where I am going to try to clone Among Us in JavaScript using Phaser.js. The starting point is a boilerplate repo for Phaser that uses Webpack, and I did a repo and a branch called P1 start, which is where I'm at right now. So after I finish the first part, I will put that in a branch called P1 end, which probably will be the same as P2 start and so on. So this is part one, and what we are going for this video is to have the ship. It's called something, let me Google that real quick. The Skeld. It's called the Skeld. We're going to take a fan-made version of the Skeld, and we're going to try to map out the borders, all the walls and the tables and basically all the objects which you cannot pass through. And then we're gonna have movement from the keyboard, we're gonna animate the player running and make sure that you can't run through things that you're not supposed to be able to run through. That is the goal for this video. I have added two assets. This is just the logo that you saw bouncing around, and here we have the player sprite and we have the Skeld, which looks like this. So it's not the Skeld that you're used to. This is a fan-made version of the Skeld. The only real JavaScript file that we have right now is this index.js. We import Phaser, import the logo for the example, and we have preload, we have create, and we're also going to add an update function that will run on every frame. And here we have some configuration. So our first step would be to add the Skeld and the player. Let's copy this line here and we change it to ship image. And it's called ship. This one we can call player sprite, because it's not just a single image, it's a collection of images. We'll call it player.png. And we can copy this line and change it to ship. So this loading of the images is done in the preload. And for the sprite, we do this.load.spritesheet, and we'll call that player. And to the sprite we need to pass some options as well, which is frame width and frame height. Frame width and frame height. And we might want to use this player height and player width later, so we should put those in a separate file where we collect all of our constants. So we can we'll export a const here, and we can call that player sprite width sprite. So the height is easy because this image is 128 pixels high. But to get the width of the frame, we need to take the width of the image and divide it by 2, 4, 6, 8, 10, 12, which will be 84. So the width is 84 and the height is 128. So now we can import player sprite height, play sprite width from constants. So now we preloaded the images, and as we can see for the logo here, we need also to, in the create method, we need to add the images to the scene. And if we need to do anything else with the image, we can create a reference to it like they do here. chip. So these two parameters are the XY coordinate where it should start. So we'll just, since this is a very big image, we'll place it at 0, 0. Let's get rid of this logo. And remove it as well. Okay, this is what we have. Okay, we have a black screen. Now it looks correct. There we go. So I missed the dot slash on constants. We can see the ship, and that makes sense because we haven't added the player yet. We just added the ship image. So now let's also add the player to the scene. Player this add Sprite. Let's create constants for the starting position of the player. Start X and start Y. We'll set it to 330 and 10. Start X player start. There we go. So now we also need to change this to player. There we have it. So we have the ship and the player, and as we can see, it's drawing the first frame in this sprite sheet. The next thing we could do is to add the update method. So what is something we want to do at every frame? Well, we want the camera of the scene to follow the player, so the player is in the middle of the viewport at all times. And I also want to change this viewport to be 16 by 9. I also want it to look a bit nicer, so I will do display grid and place items center, and also min height 100 viewport height. There we have it. And maybe we should also canvas border radius 12px. That looks a bit nicer. Now it looks more like a screen. So now let's see if we can center the camera. So to access the scene, we can do this .scene .cameras .main center on. So we do center on, and we pass x and y coordinates. So it will be player.x, player.y. So let's see if anything happened. No, yes. Cannot read property main of undefined. So let's see. Sol this dot scene. Okay, scene dot scene. Okay, so we have a default scene, and in that scene we have a scene which is my game. Okay, so the first scene is default, and then we have the scene my game. So I guess I do scene.scene maybe. Player is not defined. We will do this const player is an object, and then we do player.sprite here.sprite.x, because we can use this object to keep track of our own custom data about the player, and we'll have the sprite on the sprite property. Okay, now it looks like the camera moved, and we can remove this one. Maybe we should now add some keyboard inputs to this. So I will do this dot input dot keyboard on key down, and we'll pass a callback function where we get the event console log key down e.code. Let's do it for key up as well. Key up. And I will press space. Key down space. And this should say key up. Key down space, key up space. Okay, if we try the arrows, arrow left, arrow right, up, down, do a quick test here. If e.code equals arrow left player.sprite.x plus plus, yeah. So I'm pressing left and it's moving. So that's great, but it was moving, of course, the wrong way. The speed of the player should be a constant, so export const player speed. Let's try 5. Player speed, player speed. I did see the body was scrolling as well. Overflow hidden. I'm an idiot. So I'm pressing right now. I realize that I want to be able to hold down the key, but if I hold it down now, it's like moving once, waiting for the timeout, and then it's like jumping, like the way you would spam a key by holding it down in a text editor. Instead of doing it like this, let's have an array of pressed keys. We will just do pressed keys dot push e.code, and here we do pressed keys dot filter not equal. Okay, so let's check if we already added the key to the pressed keys. Includes. So if it's not included, and then we set pressed keys. So we add it if it's not included, and then we filter it out on the key up. And then we can move the player instead in the update. I have this as a function, pressed keys and the player dot sprite. So let's create a file, movement const move player. We get keys and player for the sprite. We can call it player sprite or just player. If keys dot includes arrow up, then player dot, we need to import player speed from constants. Player dot y equals player dot y minus players. And let's do the same for all directions. Down, plus, left, right, x. So for left we should minus and for right we should plus. Okay. So now we should just be able to call move player, and we need to import it. Import move player from movement. Okay, let's try it out. Okay, we have an error on key up somewhere. There we go. Okay, object is not a function. Is it something wrong with the export? Yep, export. Now maybe. Okay, let's try it out. Ooh, whoa. Assignment to constant variable. Let. Okay, let's see. Oh no. Seems a bit fast. 3. Yeah, let's keep it at 3 for now. But yeah, let's fix the size of the sprite because it's too big now, and let's create the animation after that. Player.sprite.display height is, yeah, we need new variables for this because we don't want the player to be as big as the original sprite. We want to make it smaller. Player height width, we'll make it 50 by 37. Height with, okay, let's see if it became smaller now. Yeah, good. Now let's fix the animations. So then we do this.anims.create. We have to give it a key. We can call that running. And frames, we can do this.anims generate frame numbers from player, and we set the frame rate. We can set that to 24 because it was 12, so it will run, if it's frames, it will run 2 times every second. Should be. Repeat -1 const anim. Let's follow the same pattern here. Animate movement, and we pass in the pressed keys and the anim. We can store this on the player. So we can pass in the player.run animation. So let's create a file for that. Animation.js. Export const animate running. Takes in keys and run animation. Running keys is equal to an array. You will say arrow. So we can create an array of all the keys that indicates running. Arrow left, arrow right. So now we can check are any of the running keys pressed. If keys dot sum key, then we do running keys dot includes key. So now if any of them match, we want to do run animation dot play, else run animation dot, is it stop? Animate movement from animation. Okay, let's try. Cannot set properly stop of undefined Asian. There we go. Still an error. Run animation dot stop is not a function. Oh, we need to do sprite. So if we pass in a sprite, then that sprite can call play and pass in the key of the animation. So we don't need to store this, we just need to call on the sprite, we call play on running, and then it should work. So now we run. No. Place it at player. Okay. So let's see if we arrive in here or if we have an error. Yes, player.play running. Let's do console log run stop. Yeah, okay. Unless we are restarting, we might be restarting the animation all the time. So maybe we need to check if it is running already. So let's do player.anims.is playing, not be playing if we should start it. If we didn't get any key and it was playing, then we stop it. So let's see now. Okay, so if we have a movement key and the animation is not playing, we start it. Else if we don't have a running key and the animation is playing, then we stop it. So now it might work. Yes. So now it does work. We should add in this movement, when we press left, we should do player.flip x true, maybe. Flip x false. So now we might turn around. Yes. That's nice. Okay, the last step is to create bounding boxes. For example, around the tables and through the walls and so on. So how would we go about to solve such a task? Okay, so I took the ship into Adobe XD and I painted all the boundaries. So the plan is that you're not allowed to step into the bright green pixels. So my plan is to create a node script that finds all of these green pixels and then marks them as not allowed to walk onto. So I will export this as a PNG and call it ship mask. Okay, now we have our ship mask here. We're going to create a script called create bounds from ship mask, from mask.js. So we're going to need fs, because we're going to read the file, or we're going to save a file at least. I found this library called PNG.js that we will have to install. And let's create a constant for our image width, which is 2160. So let's install npm install png.js. So this library will create a long array for us representing the pixels. In this pixel array it will be RGBA and then again RGBA. So we need to start like dividing these into groups of 4 to get the actual pixel values. So we can call png.decode and we pass in shipmask.png, and then we take a callback function and we get the data passed into that one. So let's create a variable where we store the result. For let I start at 0, I is less than data.length, and then we can increase I with 4 for every round. So we can calculate what row we're on by doing math.floor. So the current index divided by 4 for the RGBA, and then divided by the image width, because every pixel in row will have 4 values, RGB and A. So that should give us the current row. So if now I can access the red pixel by doing data I, and if this pixel is only green, it will be 0 for the red and data I plus 1. Then we're at the green pixel. That one should be 255 because it's 100% green. And for I plus 2 RGB, now we're at the blue pixel. The blue pixel should be also 0. If this is correct, 0, 255, 0, that means that we are in fact on one of these green pixels that are not allowed to be walked on. So we should add this to the result object. So we want to do basically result.row. Per row we push. First we have to check if we pushed anything there yet. So if result row, if it's undefined or if it already is an array. So if it already is an array, then we can do result row dot push. And what do we want to push? We want to push divide by 4 for the RGBA, and then we do modulo image width, because that's how we get the x coordinate. Because every time it goes to a new row, it will start at 0 again. So if I divide it by 4 and then modulo the width of the image, I should get the x value for that specific row. And we do something similar if we didn't have an array there yet. We need to do result row is equal to a new array, and then we'll just take the same value again. Divided by 4 modulo image width. So this result now should have, for the properties, it should have the rows, and then it should be an array of all the x values that you're not allowed to walk on. So we want to write this to a file. Write file sync. We can call this file mapbounds.js, and if you want to create it like an exported JavaScript variable, we can do export const map bounds equals, and then we can add JSON stringify result. Create a launch file Node.js, and then we say run source create bounds from mask here, and when I press play it will run this file instead. Okay, so the reading of the file went well, and if we look at this data here data, it's a huge buffer of data. Okay, now it found a green pixel on what row? 37. Yeah, that could be true. Yeah, so on line 37 it had a bunch of them. On 38 it had just 2 green pixels. On 39 it had 3 green pixels. I don't know if it's correct, but it could be correct. So we'll let it write that file. So now we should have a mapbounds.js that has export const map bounds equals, and then this huge object. So now we need to move this into source, and inside the movement we need to import it. Map bounds const is within movement boundaries. It takes an x and a y. So we return map bounds, because the row is the y. If it matches on the y, if it doesn't match on the y, we can return true. But if it matches on the y, we can look map bounds y, and this is a huge array of x values, so we can do includes x. So if we don't match the row, we can return true immediately. But if we did match the row, we have to check that it does not have that specific x. But if it does, it will return false, because then we're not within movement boundaries. So this we have to do before each move. So we need to do is within movement boundaries. Now we just have to do the same for all directions. Is within boundaries x, y, plus player speed. Here instead take player x minus player speed. Player y. Here it's player x. And this is movement boundaries. Player x plus player speed. Player y. Okay, so now if we are heading towards one of those pixels that was painted in green, we should not be able to move there. So let's try it out. Or let's see if we have any errors. Oh, I need to start the build again. npm start. See if we have any errors. No errors. Okay, so I can tell that there are boundaries. So it's sort of working. I can tell that there are boundaries, but they must be misaligned with the image somehow. Because when I walk here, I can't go down. I think I may have to calculate the absolute position of the player in relationship to the mask. Let's create export const ship width 2160 and ship height is 1166. Ship height and ship width. So now we should be able to calculate the absolute position of the player. const abs player x equals player.x plus ship width divided by 2. And for the y, ship height divided by 2. Because I think otherwise for the player, the middle of the field is 0. And we want the player's 0 to be in the top left. Because that's the x and y coordinates of the map bounds. They are referencing the top left corner as 0, 0, whereas the player's 0, 0 is the middle of the ship. So that's why we calculate this absolute. Player x should be abs player x, and player.y should be abs player y. Okay, let's see what happened now. Oh, look, we're colliding with the tables now. Okay, so it seems to, the x seems to be good, but the y offset seems to be a little bit bad. So let's look at this and try to correct it. So for this one, we could add maybe 20 pixels. Yeah, that looks nice. That looks quite natural. Can I go down here? Yeah. So now I can actually run around the entire ship. And collide with the ship, or with the green shape that I was able to draw in Adobe XD. So that's pretty cool. So now we have movement, we have running animation. And let's stop the first part of creating Among Us in JavaScript here. Thanks so much for watching. Hope you learned a few things about Phaser.js and that you had a good time watching the video. So if you liked the video, give it a thumbs up, and if you like the content, then subscribe to the channel. See you next time!